Question number 1 is the sequence an is a solution of the recurrence relation an equal to minus a sub n minus 1 with n greater than or equal to 1 with a not equal to 5 if an equal to 5 times of minus 1 to the power n. So to verify if the sequence an equal to 5 times minus 1 power n is a solution to the recurrence relation an equal to minus times of a sub n minus 1 with the initial condition a not equal to 5, we need to check two things. First, you have to calculate whether a not equal to 5 or not. So it is very simple. Replace n equal to 0, then you will get 5 times minus 1 to the power 0, that is equal to 5. So the initial condition is true. Then you have to take an equal to 5 times minus 1 to the power n. This is what given in the sequence. Then if you see this one, you need to calculate a n minus 1. So to obtain a n minus 1, what I do, I have to replace n by n minus 1. But what is given here? We have given a n equal to minus times of a sub n minus 1. So to write this, what I do, minus this a n minus 1, we will take this value. So that is minus of 5 minus 1 to the power n minus 1. Then I can write this as minus 1 minus 1 power n divided by minus 1 power 1. This is nothing but minus 5 times minus 1 to the power n divided by minus 1 power 1, which is nothing but minus 1. So cancelling these two minus, we will get 5 times of minus 1 to the power n, which is nothing but an. So we have start with an and we have conclude this is equal to an. So I can say the recurrent relation hold for n greater than or equal to 1. Next question, same thing. First we have to check a not equal to 1. So here replace n by 0, you will get 2 to the power 0. So we will get a not equal to 1. Then we have to take an equal to 2 to the power n. Then see this one. So I need an minus 1. So an minus 1 is nothing but 2 to the power n minus 1. That is replace n by n minus 1. But I need 2 times of an minus 1. So what I do, I have to multiply this result by 2. So we have 2 times 2 to the power n minus 1. So this I can write 2. This 2 power n minus 1 can be written as 2 to the power n times 2 to the power minus 1. So we have to multiply by 2 to the power n divide by this 2 to the power minus 1. This negative exponent will become positive exponent. Now by cancelling 2 and 2, we will get 2 power n. What is 2 power n? This is nothing but an. So I say left hand side equal to right hand side. The recurrence relation is true. Another question. So here we have given two initial condition, a not equal to 5, a1 equal to 10. So what I do, first I have to replace n equal to 0 here. Then I have to substitute n equal to 1 here. So that will give you a not equal to 5 and a1 equal to 10. Then you have to start from an equal to 5 times of n plus 1. Then you have to calculate an minus 1 and an minus 2. So as usual, an minus 1 is nothing but 5 replace this n by n minus 1. So we have n minus 1, but remember there is already plus 1. If you simplify, this is equal to 5n. Then for a n minus 2, we do the same thing. 5 multiplied by replace n by n minus 2 plus 1. So this will give you 5 times of n minus 1. By simplifying, by expanding this, you will get 5n minus 5. Okay, now take this whole thing. So we have 2 times a sub n minus 1 minus a sub n minus 2. So what does this mean? This means I have to multiply 2 with a n minus 1. So this is my an minus 1 answer. I have to multiply by 2. So we have 5n. This I have to multiply by 2. So this will give you 10n. Then I have minus an minus 2. So this is my an minus 2 answer. Remember, you have a minus sign outside. So I can write this as minus 5n. This minus 5 will change to plus 5. So we have 10n minus 5n plus 5. By comparing this, you will get 5n plus 5. Taking 5 as a common factor, we will get 5 times of n plus 1. Okay, this is nothing but an. So we say left hand side equal to right hand side. The recurrence relation is true. Same question here. So let us begin with an equal to minus n plus 2. First you have to calculate an minus 1. So that means we have to replace n by n minus 1 plus 2. By simplifying this, you will get 3 minus n. Then an minus 2. So this will give you 4 minus n. Then I have to find 2 times an minus 2. So that will give you 8 minus 2n. Then we will substitute this value in this sequence. Okay. So here, this an minus 1, you have to take this value, 3 minus n. Then 2an minus 2, you have to take this value. That is plus 8 minus 2n. And after that, you have 2n. So write 2n as it is. Then we have minus 9. Write minus 9 as it is. So here, this and this get cancelled. We have minus n. 3 plus 8, 11. 11 minus 9 will give you plus 2. So this is nothing but an. It is already given in the problem. So we have to start with an and we conclude this is equal to an. So that means left hand side equal to right hand side. The recurrence relation holds true. Next one, summation of sigma j equal to 0 to 8, 3 times 2 to the power j. So what is this meaning? Summation means we have to start from j equal to 0, then replace j by 1, j by 2, etc. up to 8. Sigma means we have to add every term. Okay. If you observe, you will come to know the first term of the sequence is a equal to 3. Because if I substitute j equal to 0, what you will get? You will get 3 times of 2 to the power 0. 2 to the power 0 is 1. 1 multiplied 3 will be 3. So we say that the first term a equal to 3. And then if you observe, we will come to know that the common ratio r is equal to 2. So how to find common ratio? You have to see the base value. Then the number of terms. How many number of terms we have? J starts from 0 to 8. So you have to start from 0. This is your first value until 8. So that means you say number of terms n equal to 9. So here we are going to use the formula for finite geometric series. So there is a formula you have to remember. Sn is equal to a r to the power n minus 1 divided by r minus 1. What is a? A is my first term, which is 3. What is r? R is the common ratio, which is 2. What is n? Number of terms, which is 9. So 9 minus 1 will give you 8. Divide by r minus 1. So 2 minus 1 will give you 1. By simplifying this, you will come to know S9 is equal to 1533. So this is one of the method. Another method, you can add each terms manually. That means first you replace j equal to 0, then you replace j equal to 1, j equal to 2, keep on replace j equal to 8. Then if you add all this value, you will get 1533. Same question here. So here a equal to 2, the common ratio r equal to the base value. Here we have minus 3. Number of terms n starting from 0 to 8. So n equal to 9. Then this is a finite geometric series. So Sn is equal to this formula. If you substitute A value and R value, you will get 9842. As I said before, you can add each term manually also. Same idea here. So here I have to find the summation j starting from 100 to 200. And we have j here. So this is a arithmetic series. So what do you mean by arithmetic series? If I replace j by 100, you will get 100. Then j by 101, j by 102. So every term increase by 1 with the previous term. So here the first term a is equal to 100. The last term L, which is equal to this value 200. So how I find number of terms? So number of terms is nothing but upper limit minus lower limit plus 1. So here upper limit is 200 minus lower limit is 100. Then I have to add plus 1. So we will come to know n equal to 101. So since it is an arithmetic series, we have another formula to calculate Sn. So Sn equal to n divided by 2, that is number of terms divided by 2, multiply by first term plus last term, a plus l. So here what is n? N is 101. So I can say S101, that is equal to 101 divided by 2 multiply by a value 100 plus l value 200. So this is nothing but 101 divided by 2, 100 plus 200, 300. If I cancel 2 and 300, you will get 150. If you multiply 101 with 150, you will get 15,150. Next question, we have given summation j starting from 99 to 200, but here we have j to the power 3. So this is nothing but sum of cubes of first n natural numbers. So you have to remember another formula. The formula will be sigma j equal to 1 to n j to the power 3, that is equal to n times of n plus 1 divided by 2 the whole power 2. But here we calculate the sum up to 200 and then subtract the sum up to 98, because the question is sigma starting from 99 to 100, 200. But the formula is j varying from 1 to n. Okay, so we can write this as sigma j starting from 1 to 200 j to the power 3 minus sigma j starting from 1 to 98 j to the power 3. So we have to apply this formula separately here, this formula separately here. So if I apply this one, the first one, sigma j equal to 1 to 200 j to the power 3, you will get this answer. It's a big number. Okay, then we have to find n equal to 28, because here the total number of terms are 28 for the second summation. If I use the same formula, you will get this value. Then how to find the total sum? The total sum is sum of this term minus sum of this terms. So by subtracting this value from this value, you will get this as your final answer. See you in the next video.